Hi, my name is Kyle Houchins. I'm a tech and a trainer for McNeil, and I wanted to talk to you today about subds and some of the ways that you might not have thought about interacting with subds using the UDT tools that have been in Rhino for a long time. So I built this little swim fin, and we're not going to look at it too closely because the inside is really not finished, but the topology on it is fairly regular, and it's the type of product that might require a lot of finessing and adjusting in the prototype process. Anything that has to fit on the body obviously requires a lot of tweaking, so anytime I've worked on anything like this in the past in my consultancy, I would print and test and print and test and print and test and then do all the tweaks in between. And Subd offers you a really unique ability to be able to operate within that cycle in a very effective and kind of very useful and very repeatable way. And when we combine this with history and copy and a few things like that, it opens up a whole bunch of possibilities that you may or may not have thought about in the past already. So with that said, we're just going to take a quick look at this thing. It's basically a single piece. It's got fairly simple topology. It's got a strap in the back and things like that. And so opportunities for adjustment may be something like maybe the arch needs to get taller or thinner, or maybe the footbed needs to get wider or narrower, or maybe the shape of it needs to be optimized after we test it in the pool and find out that it doesn't have enough strength when you're kicking or something like that. And so that process, design, iterate, test, repeat, is something that I go through a lot as a designer, and I'm sure you do too. And Rhino has this transform palette up here that allows you to be able to go through and do a couple of different things. And the idea behind here is I just want to show how the UDT tools work with subds. And one of the differences between a subd and a NURBS object is if I apply a transformation or a UDT tool to a NURBS object, you may have noticed, especially if you deform it a lot, that the surface rebuilds and gets very complex and can sometimes be difficult to deal with. Subds don't have that problem. They stay nice and light no matter what you do to them. And so one of the first things that I want to talk about is twist. And if I turn, I made a line here, a reference line, so I can show you how this works. But if we go up here, the first one in the list here is twist. And if I click on twist, it says select the object to twist. Well, I'm just going to select my subd. The start of the twist axis is going to be down here. The end of it is going to be here. Think of this as like the axle on the wheel of a bicycle. And then the angle of the first reference plane is going to be over here. So say we were making a right and a left, and we wanted the front of the fin to be slightly different. Well, we can simply just twist this a little bit and add a global twist to the entire object. Now, the nice thing about twist is I can apply it to just part of the model. So if I come in here and I select just a piece of the subd, I can select twist. I can pick my axis from here to here, and I can rotate just that end. And you'll see that I can affect just a piece of the model without affecting the rest of it down there at the end like that. Okay, so that's twist. The one thing that I also want to point out about subds is they're very, very robust. And one of the ways I like to demo this is actually using twist. And if I take this thing and I twist it, let's say I twist it one full time. Okay, that would be a pretty effective demonstration to show you that the twist is effective and that the subd works. But let's get a little crazy. Let's go 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go around there 10 times. And you can see that although it makes a big giant mess, the subd is still a valid subd. I can still extrude it. I can still do all sorts of stuff that I'd want to do to it. I can interact with it. The other thing that's amazing, even though this is a jumbled mess, is I can actually run the toNURBS command, and believe it or not, it will make a NURBS object out of this that is one open poly surface. I think it was open to start with, but the only places that it were open on the subd is the only places that it was open on the model. This is all valid, essentially polysurface data. Now, you'd never do that, but I like to use it as a demo to show just how durable this stuff is. Okay, so let's go to the next one. The next one on the list is bend, and bend is particularly effective in subds. Let's go to the side view on this thing and take a look at it. So it's got this nice kind of sweeping profile, but what if we decided that the tip of this thing needed to come up a little bit more, right? And we wanted it to be nice and smooth over the length of the object. Well, I can simply select the object. I can decide where I want this bend to happen, and look how nice and controllable this is. I can either add more bend to it, or I can take some of the bend out of it and then redo the bend so that it's much gentler. And you can see that all that's done with a nice procedural process using the bend tool. Okay, so let's go back to the original. So that's bend. The next one is taper. And taper is also super useful because say that we needed some more surface area on the front of this thing. Well, I'd simply pick the object to taper. I'd set my axis. I'd pick my start and end points, and then I can either grow the front or shrink the front to make a different shape. So maybe this is a big mega fin of some sort. All right. If I want to modify this end down here, I'm going to pick the object. I'm going to start down here. I'm going to go up here. I'm going to set this as my start, and then my taper happens down here. Okay, so it just depends on which end of the line you pick. If I want to do this end down here, I'd pick the object to taper. I'd start down here. I'd set this as the starting point down here, and then I'd be able to stretch the front of the fin like that. Okay, so that's taper. The next one I want to talk about is flow. And flow is a very interesting one because it allows you to have a starting curve, right? So I've just drawn a curve that represents the shape that I'm kind of starting from. And then I have a new curve that represents where I want to end up. And if you notice down here, I've got history, always record history and update children. This allows me to be able to iterate with this thing after I've applied this. So let's do flow along curve. I'm going to pick the object to flow, which is going to be the whole object. And then the base curve is going to be the first curve I drew. And then the target curve is going to be the one down here. And I'm going to use the copy option down here because this is going to allow me to iterate without destroying my original object. So I'm going to just go ahead and use the copy option to yes. And I'm going to click down here, and you'll notice that the object is remapped from this curve onto this curve. And the cool thing is because this is historically enabled, if I move that curve, then that will actually update. So if I turn the points on from my original curve, talking about history, I can now iterate by pulling this curve around, and I can actually change the shape of the object to do what I want to do based on what I do with the original points. So this gives me an opportunity to make a copy, right, in that design, test, iterate, repeat, or design, iterate, test, repeat, however you want to approach it. And it allows me to be able to take and make more than one copy. I could do this several times with several different curves, and then I could have several different prototypes very, very quickly in order to be able to test them to see which shape works the best. Okay, so that's a really, really super powerful one because it allows you the ability to be able to go in and iterate later and very simply make global changes to the thing as you see fit. All right, so I'm going to delete that one. And the next one that we're going to talk about is shear. And shear is misunderstood in a lot of ways in the fact that basically what it does is it allows you to just take something and kind of lean it. And so if I shear this and I start shearing this object from here, you can see that I just lean it. But the thing that you'll notice that's interesting about it, let me draw a line up here for reference, is it actually will keep it about the same aspect ratio. So it kind of not only leans it, but it also stretches it. So you'll notice that it's not getting any farther away from this line. It's not like a rotation. A rotation would do this, and you'll see that the nose actually, the end of that thing actually tracks away from the line. Shear actually just simply leans it, which can be super useful. Now I'm showing all these in a global a global affection of this model. It doesn't have to be global. I can actually select just a piece of this model, and I can shear just this part. And because it's a sub-D, it's going to stay nice and smooth. That's one of the beautiful things about using these transform tools on sub-Ds. All right, so let's talk about the next one. The next one would be flow along surf. And you'll see that here I'm going to actually end up using two surfaces. I've got one surface here and one surface here. And I'm doing this in rendered mode, so let's do it in shaded mode so you can see what's going on. So I've got, this is my target surface, or I'm sorry, this is my base surface, and this is my target surface, a lot like flow along curve, where we had a base curve and a target curve. We're going to do the exact same thing, except we're going to use surfaces. And the cool thing about the surfaces is it gives you more than one dimension of mobility as far as your transformation is concerned. These are both degree 3 surfaces. And so if I flow along this surface, and I take this object, and I use this as my base surface, and this is my target. Again, I'm going to use the copy option. You can see that what it does is not only does it follow the contour in this direction, but it follows the contour in this direction. And because we did this with history on, if I come in here and I grab some of the points of the target surface and modify them, you can see that I can actually affect the model in ways that are really kind of interesting and useful. If I want to make the front just a little bit wider but leave the rest of it alone, you can see that that transformation happens like that. Let's do it a little more so you can see what's going on. See that? And the cool thing is the history is bidirectional. So not only is this object historically linked to this object is historically linked to this, but these two objects relate to these two objects. So if I take this surface and I move it farther away, watch what happens. This thing actually grows farther away from the surface below. See that? If I move it closer, you'll see that the object actually gets closer to the surface. And if I were to move it above, you can see that it actually will transform underneath the surface and compress it based on the curvature of the surface below it. So this is super useful because not only can you modify the object down here to get some interesting things going on, right, like this, but I can also modify this relationship up here and say, modify one side. So say I was making a right and a left. I could modify one side, and then as I change this down here, you can see that it changes these shapes down here. So it's almost like a remote control system where you can design things where this is your remote control and this is your result. But it gives you a whole bunch of freedom in order to be able to iterate and design things and make modifications. So typically what I would do in this type of scenario is I would have, you know, a fairly subtle difference. I would maybe map from one to the other, and then I would just use these objects to iterate in order to get the shapes that I want. Maybe I needed to add a little bit more instep or a little bit more arch or something like that, and that would be an easy way to do that. All right, so that's flow along surface. So the next one I want to talk about is cage edit. And cage edit is one of my favorites in the fact that it's super, super easy to understand. And let's say you've got a model that's got a ton of subdivision in it. Let's take this and subdivide it and make it so that it's got too many faces where it would be practical to be able to edit this, right? Because if I turn on my vertices or my control vertices, you'd see that it's got a million points. And so if I touch any of the points on the surface, I'm going to put a dent in it, right? There's no way, there's just way too much data here in order for me to be able to edit this thing in a way that makes any sense whatsoever. So in that case, what I would do is I would come in here and I would do a cage edit. I'd use the bounding box of the object. I'm going to use world coordinate system. And in this case, I want to do a really low, point count cage. So I'm going to just do 4 and 4, and I'm going to use degree 3 on both of those. So I'm going to accept it, and then I'm going to make a global region edit on this. And you'll see that what I do is I end up with this kind of control cage of points, right? I can grab each one of these points, and now as I make edits to these smaller parts of the cage, the model's going to update. Now this is a very dense model, so it's got a lot of calculations to make, but this is the example, you know, this would be an example of how to use it at the higher end. So you can see that once it finishes calculating, it makes the edit, but it also makes the edit smoothly. So let's look at a more realistic way of using this, and let's back up a little bit. And I'm going to undo my subdivisions and go back to my regular light model. But let's put a little bit denser cage edit on it. Bounding box, world coordinate. Let's do something like 6 and 6 and 6. So we've got more points to play with, right? More opportunity to make edits. So we've got 6 in this direction, 6 in this direction, 6 in this direction, right? So what I can do is I can actually come down here and on a little bit more granular level make adjustments to this based on what I want to do. Maybe all I want to do is just bend the tip up just a little bit, but I want to leave the rest of the model alone. And maybe I want to sink this part here, so I'm going to pull that down. And you can see that those little changes allow you to be able to kind of mess with the shape a little bit and get kind of very interesting things. Like say for instance, if I were to grab just these points here and say cell V, I would get just the points in the center of the model. Well, that would allow me to be able to add a little bit more room in the arch, right? Like that. Okay, so it gives you a lot of control and be able to do that in a kind of unusual way. The way I typically use cage edit, I'm going to back up again, is I actually make fairly low density cages, like 3 by 3 by 3. And this allows me a very simple cage with very simple editing capabilities, and allows me to be able to do things like maybe I do want to do a right or a left, and I need a little bit more room over here on this side. I can just pull that out and then add some asymmetry to this thing that would then make this more appropriate for a right or a left or something like that. Okay, maybe the strap is too wide at the back and I just need to shrink that a little bit. Maybe I just need to pull up the top of the strap but not the bottom, so I just grab this top points here and I'd pull that, and you can see how this pretty much stayed put, whereas this grew a little bit. So you can see the iterative possibilities of being able to do this with cage edit is super useful. And the beautiful thing about how subds react with this is all of the stuff ends up staying smooth, which I just think is fantastic. All right, so let's go back to where we were. The last thing I want to talk about is soft transform. And let's go back to our transform menu, which is this option here. And when I click this, you'll see that it gives me a couple of options. I can have the option to enable or unenable it. Enable yes or no. I've got a radius and then I've got a shape. The radius, let's start off with something small like 2. And then you can see if I just right click, soft transform is now enabled. That means that when I do a transform, it's going to have the soft transform applied to it. So if I shift control click, say this piece right here, and I change it, you'll notice how that transformation is spread out over a farther area than it would have been had I done this with, let me right click and disable this. So you'll see with soft transform enable set to no, if I shift control click on this edge, the transformation happens just within the edge itself, right? If I turn this on and enable it, and I set my radius to something like 5, then you can see that that same transformation affects a much broader part of the model. So this is a way, if you're getting into sculptural details, it allows you to be able to, and this affects all transforms, by the way, so move, scale, rotate, it all happens with the soft transform turned on. So say, for instance, I pick just these faces and I want to scale them. You can see how that affects the entire model with that enabled, whereas if I set enable to no, and I do that same transform, it has a much different effect. It just happens locally. So between toggling soft transform on and off, it allows you to be able to go in and really finely tune your selections and your modifications in order to get, you know, really nice details with features that flow very nicely into each other. All right, that's about all I have for you today. I just wanted to show you a couple of those tricks with Subd and the transform commands. I hope you are enjoying Subd as much as I am. If you have any questions, hit us up, tech@mcneil.com, hit the chat on our webpage, or give us a call on tech support, and we'd be more than happy to chat with you about it. I'm Kyle Houchins. This is Using UDT Transforms with Subd. Go make great stuff. Thanks.